Hi friends, this is Dr. Nitin Kumar Saxena. In my previous lecture on electrical charge, we have seen how the electrical charge behaves, what is the value of the charge, how they behave with different types of charges, how they feel attraction or repulsion force depending on the polarity of the charges. So first of all, we see a concept like we know that if we have two charged particles and they are placed with each other, they will naturally experience a force. And I have told you in my last lecture that force is a vector quantity because we can find the magnitude of the force by the Coulomb's law. Force equals to something constant q1 upon q1 into q2 upon r square. And at the same time, since the direction of the force may be attractive, may be repulsive, that depends on the quality, on the property of the charge, whether it is positive, both the charge are positive, negative, or some one positive and one negative. Now, I want to see if I have more than one charge, more than two charges, then what will happen? So for this, the topic is force due to multiple charges. Force due to multiple charges, right? Suppose I am having number of charged particles. For example, I am taking suppose 1, 2, 3, 4, 5. May this 5 may go up to the any number of charged particle, and in that case in general we can say that n number of charged particles. Suppose I am saying this is the charged particle 1, this is 2, this is 3, this is 4, this is 5, and we are going up to the last point is n, right? So naturally, if you see, all the charged particles are placed in a space randomly. Okay, so randomly means they are not like see point 2 is here, 3 is here, 4 again here, 5 here, and so on. So they are not in line, they are not in particular symmetry, so we will say they are in random space, randomly placed in space, right? So if I want to know the force on the charged particle 1, suppose the charge for this particle is q1, and the charged particle, suppose I am saying the charged particle, this is the value of this charged particle is q1, right? The value of this charged particle is q2, for this q3, for this q4, for this q5, and for last qn, right? And if we see, I'm saying the distance between 1 and 2 is given by r12. The distance between 2 and 3 are given by, and so on, and so on we can calculate. So like now that I'll continue, that if I'm saying that suppose first we see a case of only two charged particles. Suppose this is q1, this is q2, and I am saying that these both the charged particles are positive in nature. So what will happen? They will experience a force. They will experience a force, and this force will be of repulsive type. So I am saying the force is, say, I want to see what will be the value of force on charged particle 1, on charged particle q1 due to this q2. So how will you find this? 1 upon 4 pi epsilon naught q1 q2 r1 2 square r12 cap. What is this? If I am writing like this, so if you see here, the value is given by this formula 1 upon 4 pi epsilon naught q1 q2 r12 square with r1 cap. So this r1 cap gives the direction of the force, right? So direction of the force can be find out by this cap, because this force is a vector quantity. So if I write only this term, which I have given in your last lecture, so this term gives only the magnitude of the force, this Coulomb force between the charge particle q1 and charge particle q1. But since I also require the direction of this force, so I have to write some direction for this, and the direction of force is this r12 cap, right? So r12 will give you the direction, and you know from the basic knowledge of your vector that this is something like this. So this simply means, if you see, the A cap is given by the vector A divided by mod of A. So the magnitude for this will be unity. Always the value of the magnitude will always be unity. And hence we can say here also this R12 cap will give you only the direction. The magnitude of this R12 cap will be unity. So in that way you can say the value of the force will remain same as it was in the previous case, but since the force is a vector quantity, so I cannot write without a direction, and hence this R12 cap gives the direction. Is it okay? Now in same way I just want to know if in place of one charge particle we have number of particles, and I want to know what would be the value of force at charge q1 due to all these charge particles. So question is clear to you? The question is that we have n number of charges, the values q1, q2, q3, q4 up to qn. So I want to know what would be the final force on the charge q1 due to the all charges, that is from q2 to qn. So simply how can I do this? So to do this, what can I do now? What I will do? A simple thing. Suppose this is So the force I want to know at this charge 1. So I have to write the distance between 1 and 2 is r12. The distance between 1 and 3 is r13. The distance between 1 and 4 is r14, r15, and up to r1n. Right. So this is the magnitude. This is the magnitude of the distance. Now again I am saying that I want the direction. So how can I write direction? So for direction, what I will do? I will put cap over there. Right. So this gives the direction for the force, right? Now the value, suppose the force on 1 due to 2. So what is this? This is force on 1 due to 2, right? And if I write its value will be 1 upon 4 pi epsilon naught q1 upon q2, q1 into q2 upon the distance between these two is, the distance is r12 square, and for the direction what I will do, r12 cap. This is okay, right? Again see, similarly if I write f13, what is f13? The force on charge particle q1 due to the charge particle q3, and what will be its value? 1 upon 4 pi epsilon naught q1 q3 upon 13, so r13 is square, right? And for the direction we will take r13 cap. This is okay. So in this way we can see that I find the value of force at 1 due to 2 and due to 3. So if I want to calculate the total force, what I will do? The total force on 1 will be the total force on charge particle 1 will be the vector sum, I'm talking about the vector sum, okay. So 1 due to 2 plus 1 on 1 due to 3 on 1 due to 4 and so on till f on 1 due to n. So the total force on charge particle 1 will be given by the vector sum of the all forces which will act on charge 1 due to 2, due to 3, due to 4 and till due to n. Right? So if I put the value of all these by the knowledge of this, so what can I do? I simply 1 upon 4 pi epsilon naught q1 q2 upon r12 square r12 cap plus this is the value of f12, the whole value. For f13, see the value of f13 1 upon 4 pi epsilon naught q1 q2 upon rq3 r13 square r13 cap and so on. I can go to the point n. So at point n what will happen? 1 upon 4 pi epsilon naught q1 qn upon r1n square r1n cap. Right? This is fine. Now you see in the whole expression this 1 upon 4 pi epsilon naught and q1 is always common. So if it is common, so what I can do, I can take it outside q1 upon 4 pi epsilon naught and now inside I can write q2 upon r12 square r12 cap q3 r13 square r13 cap. Similarly, last is qn r1n square r1n cap. This is okay. This is okay. So in general, if I want to write it, this expression is fine. It's fine. We have calculated what will be the final value on the charge particle 1. But what happens sometimes we want to make the formula in a very short way, in a very reduced way. So it will look like a very beautiful. So for that, what can I do? I simply, if you see this, I'm rubbing it for getting some space. Okay, so if you see this, f1, so f1 can be given now. So I'm showing you the value of f1. How can I write? I can write f1 is the final formula q1 upon 4 pi epsilon naught, and I'm supposing that you know this function. This function is used for showing the sum. Okay, sum of different terms. For example, if I have like 1 plus 2 plus 3 plus 4 plus up to the point n, so I can write like this: summation of n, where summation j, suppose j, where j can go from 1 to n. So what does mean? What does it mean? It simply means that this 1 plus 2 plus 3 plus 4 up to n can be written like this. What is this? You will put j equals to 1, then it will be 1, j equals to 2, then it will be 2, j equals to 3, this will be 3, and so on up to the point n. And since we have this sign and this sign represent for the sum, so what does mean? We will put plus sign between each of them. Is it okay? So the same sign, the same mathematical sign I am using here. How can I use this? So I am putting summation because we have the sum of different terms. The sum, right? You see, here we are changing the value of q subscript. What is the subscript of q is 2, then 3, then 4, then 5 up to n. So this means if I put qj, right? So this means the value of j will be from 2 to n. Similarly, you see divided by r, the first term is always constant 1 1 1, so I'll put here 1, right? And now this 2, this 3, this 4, 5 up to n, so this is j. Is it okay? This is j. And again you see r when you talk about the cap, so this is again you see the first term is always 1, so 1, and second term is 2, 3, 4, so this is again j. And what is the value of j here? J will be start from 2 and will go up to the n. So it looks very like technically complicated term, but if you will try to understand it, so what is this? That if you see this, so what is its arm? Okay, arm for your convenience, for your better understanding, arm again now I'm opening it. So if I will open it, so what I will get? So if I open it, then you see what will happen? The q1 upon 4 pi epsilon naught is always common, right? It's common. Now see, value of j go from 2 to n. So it will be 2, then 3, then 4, then 5, then 6 up to n. So first it will be 2. So when I will put the first, so q j means 2 upon r1j means r12 multiplied with r cap 1j means 1 2. So this when I put j equals to 2. Now since we have sum sign, so I will put sum here. Is it okay? So now what will happen? Now I will put q equals j equals to 3. So put again here. So q j means 3 divided by r 1j means 1 3, r cap 1j means 1 3 plus, right? Again the last term is when I will put j equals to n. So now put j equals to n, so qn upon r, now again j is n, r cap 1n and close. So you see this expression is in short as look like this. So it's better to write in a compact way. It looks technically very sound, so we can write in this way, but don't be afraid of the expression. This expression is very simple to understand like this. So in this way we can say that okay, we can find how the force for one charge particle due to multiple charges can be found by this expression. I hope that theoretically this point is clear to you. Now how can we solve the problems in which we have number of particles which are placed at some place in space, and we want to know what would be the value of force at a particular point. Okay, so for that purpose we can use a law of parallelogram. What will be the law of parallelogram? That I will tell you, and before that let me allow so to understand this, I am giving you law of parallelogram that you have already been studied in your mathematics course, but still for your convenience I am giving you the basic idea what is the law of parallelogram. So you see what is the law of parallelogram. So for this, law of parallelogram. So law of parallelogram. In this law, what we do? We simply take, suppose at a point we have, suppose first let me draw, then I'll explain you. Okay. See, at this particular point, I'm taking this as a reference point. Five forces are acting. F1, F2, F3, F4, F5. And all the five forces are in different directions. So we can say this is a vector. Why? The magnitude is this. Okay, the magnitude is this. The length of this force is taken as a magnitude, and this theta1 is the angle of this force from this reference line, right? So law of parallelogram says that we can, like, if we have one force like this A and one force like this B, so if I shift this like this, what I am doing, I am shifting this B parallelly at the head of the vector A, and now I am like trying to meet this head with this point. So what will happen? This will make a parallelogram, and this parallelogram result R is given by under root A square plus B square. So this is called the law of parallelogram that you have already been discussed in your mathematics course. So the same thing I am going to use here in different way. What I am doing, I'll do with the help of law of parallelogram, that this is okay valid when we have only two vectors, and if we have number of vectors, so we can go one step ahead, and in this step what we do, for all the forces we try to make either horizontal components or vertical components. So we will try to make either horizontal components or the vertical components. So see, for these all forces, F1, if I take its horizontal component, it will be F1 cos theta. Okay, F1 cos theta. I hope you know this. This is suppose A, this is theta. So this is called A cos theta, and this is called A sin theta. Right? So same thing I am using here. So the horizontal component of this is F1 cos theta. For F2, F2 cos theta, F3 cos theta, and so on, F4 cos theta, and last F5 cos theta. So this is the horizontal component. Suppose I am saying this FH, the horizontal component of force. Similarly, you see the vertical component FB, the vertical component of force, will be A sin theta. So F1 sin theta plus F2 sin theta plus F3 sin theta plus F4 sin theta plus F5 sin theta. Right. So you have the values of horizontal component of all the forces and vertical components of all the forces. Now the total force is given by under root of Fh square plus Fp square, and the direction of this force will be theta is tan inverse Fb over Fh. Right. So I'm saying that let this is the final force F, and this is the final theta. So the value of this F, what is this F? This is the overall resultant force on this point due to all these forces. Okay, so the total force is given by this magnitude, and the direction of this theta from this reference, is tan inverse FBF or FH. Okay, so what is the physical significance of doing this? The physical significance of doing this is that if we have a point 1, you refer the previous figure in which we have charge particle Q1 at point 1. Now we are getting the forces by all the different charge particles at this point 1. It will look like this. Okay, if I am saying this is the charge particle 1.1, so maybe this is due to second charge particle, maybe due to third charge particle, third, fourth, and so on up to n. So the figure will be look like this. We know the direction as well as magnitude of each and every force acting on this point 1 due to all the charge particle. If we solve in this way, then we can calculate the overall force on the charge particle with its direction. Right. So this is the physical significance of understanding the how can we use the horizontal and vertical component, and finally we can get the overall force and direction of the force. And since this is not a law of parallel diagram, but I am using the concept of law of parallel diagram for getting the resultant force. Okay, so I hope you have understood it. Let me allow to give you small two problems for the better understanding of this. So what I am saying now, suppose I have a figure like this. This is an equilateral triangle. This is an equilateral triangle, means all the angles are 60 degree. So this is an equilateral triangle, and I am putting 3 charge particle plus Q and plus Q at the vertices of this equilateral triangle. So what is the question? The question is, and this is the centroid for this triangle. Okay, suppose the name of this were O. So the question is find the value of resultant force on this O. Let me allow to take any charge particle Q over there. Okay, so the question is find the value of Coulomb force on the centroid of equilateral triangle okay, equilateral triangle if plus Q charges are placed at all the 3 vertices. Right? So question is clear that I have an equilateral triangle. On the 3 vertices we have plus Q charge, and on this centroid I am putting a plus Q charge, right? So what would be the value of total force on this, right? So how can I start this problem? So for starting this problem, you see that let me allow to give the name. Suppose this is A, this is B, this is C, right? So if you see all are the positive charges, all are the positive charges. So naturally all the charges, like I want to know the force on the point O. So you see point O from point A, both are the positive charges. So naturally the final force will act like this. Okay. From B also it will act in this direction and will go outward side. Also here from C, the force of the direction will be like this. Is it fine? So suppose I am saying this is a force on O due to A, force on O due to B, and this is force on O due to C, right? And suppose since I know the concept of geometry that this whole angle is 60 degree, so naturally this will be 30 degree, this will be 30 degree, similarly 30 degree, 30 degree, 30 degree, 30 degree, right? Because of the geometry, and this is the centroid, right? And now you see if this is 30 degree, and if I take, for example, I am taking this is as a reference line. I can choose any line as a reference line, any line as a reference line. I can choose this line as a reference, this line as a reference, this, anyone. For your better understanding, I am taking horizontal line as a reference line. So what I am saying, this line is I am taking as a reference line, right? So if you take this line as a reference line, so you see the FOB is making, I'm drawing here. So this is your reference line, right? So FOB, you see here, what is the angle between FOB and this reference line? Can you draw this? So what is the angle? You see by the geometry, this line and this line is parallel. So this angle will come at this point, and hence if I say this is FOB, so FOB will make this angle 30 degree. Is it okay? Again see here FOC. If FOC is from the reference line, this is the reference line. So FOC, where is FOC? FOC is like this. FOC. Okay, and you see what is the value of FOC? The angle. So you see this makes angle 30 degree. And if this is 30 degree, so what left? This one is 180 degree. So if I take angle from this line, so this will be 180 degree. Is it fine? Right? So this you see, this makes this angle 90 degree. Okay. So if this is 90 degree, so what is left? This is clear, no? You see how much this, if I allow to go it up to this point, so this is 90 degree, and if this is 90 degree, this is 30 degree, so what is the value of this? What is the value of this? This would be how much? You see, this is 90 degree, which is coming down, this is 30 degree, so naturally what is this? 60 degree, right? So if this is 60 degree, this means this is also 60 degree, or this complete is 90 degree, right? And this whole is 180 degree from this point to this point. So if I look, this is FOA. So what is the angle of FOA? 90 plus 180. So total is 270 degree. 270 degree. This is fine. This is fine. Okay. So now you see, this is the angle which I have drawn for all the three, and now if I want to find the value of FH, so what will be the value of FH? FH will be, and see one thing, that this is only due to the geometry of equilateral triangle, these all distances are equal. So when I will write the formula like this, 1 upon 4 pi epsilon, okay, I am writing for first FOA. So Q, capital Q, divided by the distance between OA, right? So because I have taken already the direction, so I am writing only the magnitude here. So you see, ROA, ROB, ROC all are equal, QQ is always equal, and hence when you talk about FOB or FOC, this always will remain same. Suppose this is F. Why it will remain same? Because you see that ROA, ROB, ROC, all three are equal. So FH will be, if this is F, this is F, this is F. So this will be F cos 30 plus F cos 180 sorry, one thing I made mistake. This is 180 minus 30, because the whole is 180 and we are minusing 30 degree. So this will be 150, right? So this will be cos 150, and last you see what will be this, F cos 270, right? So when you will solve this, F cos 30 is 1 by 2, F cos 150 is minus 1 by 2, plus cos 270 is 0, so this is 0. So finally when you will solve, this will come 0. Okay. Similarly, if I do for Fy, F sin 30 plus F sin 150 plus F sin 270. This is okay. Now I am taking the vertical components to F sin 30, F sin 150, F sin 270. See this, F 1 by, I'm sorry, this is again I have made a mistake. So again the answer will remain 0, but the value of cos 30 is root 3 by 2, not 1 by 2, sorry. So here plus F sin 150, 1 by 2, plus F value of sin 270 is minus 1. So this is minus 1. So when you will solve this, this will be F, this is minus F, so again 0. And hence what you see here, the total F, which I will find like this, FH square plus Fy square at point O will be 0. And what does it mean? It means the answer for this problem is 0. Physically, we can understand this, that if three equal charges are placed at the vertices of the equilateral triangle and we want to know the total force at the centroid of this triangle, so the total value will be 0, right? Because all the three forces will try to repel from this. So you see all the like these are equal and opposite, all the three, the total sum is 0. So this we can also analyze from the practice, that yes, total force will be 0, but mathematically we can do like this. So I am in very quick, I am repeating the whole question. So what I did, okay, this is the vertices ABC. Now I put the centroid. All we know that these angles are 30 degree at point O. At point O, the force due to A will be this, the force due to B will be in this direction, C will be in this direction, and so on. If I am taking this reference line, so this reference line is making 30 degree with FOB, and this is making the angle 150 degree, and this is making the angle 270 degree, right? So I am again drawing here. So this is 30 degree, 150 degree and 270 degree. For these three forces, if I placed the concept of resultant force by the component in horizontal and vertical direction, so Fh will be F cos 30 plus F cos 150 plus F cos 270. The value of cos 30 is root 3 by 2. The value of cos 150 is minus root 3 by 2. And cos 270 is 0. When I will put, I will get 0. Similarly, for vertical component, this will be like this. So it will be like this. So this again will be 0, and when we will solve, the whole value will comes out to be 0. And hence the answer for this problem, that what would be the resultant force on the centroid of the equilateral triangle when equal charges are placed, is 0. So I hope you have understood this problem, and let me allow a very simple next problem. What I am doing, I am using the same problem, but now what I am little changing, what I am changing, now I want to know in place of, okay, now what I am doing, I am making a very simple change. The same equilateral triangle I am taking, the vertices are A, B, C. Here charge particle is plus Q, here charge particle is plus Q. Now here the charge particle is minus Q. Right? So if it is so, this is negative, this is positive, this is positive. Now I want to know what would be the value of the force on these vertices. Right? So you see, if I do in this way, and I want to know the resultant force on the vertices A, B, C. So what will happen at point C? You see, at point C, we have two forces. One force due to a charged particle, one force due to the charged particle at B. So at C, you see, this force will be F at C due to A. Here, F at C due to B. This is clear, right? So this means if I take this as a reference line, I am taking this line as a reference line for this case. So you see, this angle is 60 degree. So this angle will also equal to 60 degree. And the whole total is 360. If I subtract the 60 from 360, what I will get? 300. So this means this FCA will make 360 degree angle with this reference line. So now what is the value of FCB? So value of FCB will be 1 upon 4 pi epsilon Q at C, Q at B divided by RCB square, right? So again, direction I have taken here, so I will take only the magnitude. Suppose I am saying, since this is an equilateral triangle, so all the three distances, all the sides will be same. So I am taking the length of the side is D. If this is D, naturally this will D, and this also will D. So when you solve this, 1 upon 4 pi epsilon QC, the value of QC is Q, the value of B is Q, right? Suppose this is also plus Q. Okay, this is also plus Q. If I will take minus Q, then what will happen? Okay, I'll do with both. So I am doing with plus, then I'll do with negative. So this upon D square, right? So similarly, F C due to A 1 upon 4 pi epsilon Q C Q A divided by R C A square, right? I am not taking the direction because direction I have already taken here. So this will be 1 upon 4 pi epsilon q upon d square, right? So you see both are equal, right? The value is equal. So if I want to know the horizontal component for this too, so what I will write, FCB cos 0, because this is in the reference line, FCA cos 300, right? Solve this. Cos 0 is 1, cos 0 is 1, so FCB plus, what is the value of this? 360 minus theta. What is the value of FCB? FCA, okay, I'm right like this, FCA cos, so 360 minus 60 is 60. So this will be cos 60. And what is the value of cos 60? The value of cos 60 is 1 by 2, right? So the value will be FCA by 2. Since these both are equal, so I can put its value. So q square upon 4 pi epsilon naught epsilon d square in bracket 1 plus 1 by 2. So this will give me 3 by 2 times q square 4 pi epsilon d square, right? Similarly, find FV. So FV will be FCB sine 0 plus FCA sine 300, right? FCA sine 300. What is sine 300? Sine 300 is minus, so I can write like this, sine 300, I can write sine 360 minus 60, so minus sine 60. And what is the value of sine 60? Minus root 3 upon 2, right? So what can I do here? I can write sine 0 is 0, so this term will be 0. And here what we will get? The value of FCA is q square upon 4 pi epsilon d square into minus 3 upon root 3 upon 2. Is it okay? So you see, now what will be the total force? So what we get? We get FH is 3 by 2 q square upon 4 pi epsilon d square, and FB is minus root 3 upon 2 q square upon 4 pi epsilon d square. So what is the final value of force? The final value of the force will be under root FH square plus FB square. Solve this. When you will solve this, what you will get inside? You will get 9 upon 4 into q square upon 4 pi epsilon d square whole square plus minus root 3 by 2 will give you 3 by 4, again in bracket q square upon 4 pi epsilon d square whole square, right? Now you see, this term you can take common, and since this is a square, so it will come outside. So what you will get? Q square upon 4 pi epsilon d square 9 upon 4 plus 3 upon 4, something like this. Okay, so when you will solve this, you will get root 3. So what will be the value? Root 3 q square upon 4 pi epsilon d square. right? And also if you want to know, the direction, so what you will do, the direction of theta is tan inverse FB upon H. So tan inverse, what is the value of FB? Minus root 3 upon 2 upon 3 upon 2. Why I am writing this? Because except this, all other things will be cancelled out, right? All other things will be cancelled out. This term and this term will be cancelled out when we divide FB and FH. So this term and this term will cancel out. So when you will solve this, what you will get? Tan inverse minus 1 upon root 3, and this is minus 30 degree or 330 degree, right? So and hence we can say that the resultant force will be this F, the value of F is this, and the value of F is this, and the angle from the reference line, because this is reference line, the angle is minus 30 degree. Okay, so if we have the 3 charge plus Q plus Q plus Q on the vertices, so what will happen? The overall force on point C, on vertices C, will be from this reference line 30 degree down and with the value of this, right? Similarly, we can find at point A and point B. Okay, I am giving you a quick review. What will happen if in place of this plus Q I have minus Q? So again I am repeating the problem. The change is what is the change? The change is that in place of plus Q and C, so what I am supposing? I am supposing this is minus Q. Okay, if this is minus Q, now you see the FCA, like on point C, on charge plus Q, it will attract, so the force FCA will be in this direction, right? While B will again repel it, so it will be in this direction, FCB, right? If this is angle 60 degree, so what is this? Rest 120 degree. This is clear, right? So this will be 120 degree. So now see, first what is FCA? FCA is again 1 upon 4 pi epsilon Q square, because this is Q, this is Q. I am not taking negative sign because the direction I have already taken here, Q square, and the distance is D square, so D square. Same magnitude I will get through FCB also, right? This is okay. Now you see, if again I am taking this as a reference line, so what does it mean? It simply means if I am taking it as a reference line, so what will happen? FH will be, okay, FCB plus FCA cos 120. What is the value of 120? FCB plus FCA. What is the value of cos 120? Cos 120 is 1 by 2 with minus sign. So minus 1 by 2. Suppose I am saying this is, since both are equal, so for simplicity I am saying this is F. Okay. So what will happen? F minus F by 2. What you will get? F by, right? So the horizontal component is F by 2. Now find vertical component. So again FCB sine 0. I have to put here cos 0 also because the angle is 0. But since cos 0 is 1, so I left that point. But if you want correct expression, then what you will write? You will write like this. Okay, let me write the complete expression for a better understanding. FCB cos 0. Right, so cos 0 is 1, so ultimately it will come FCB plus FCA sin 120. Right, so this will be 0 plus F, because I am putting FCA equals to F. Right, sin 120 is root 3 by 2. So this will be root 3 F upon. So what will be the final F? At point C, under root FH square plus FV square. Right, if I put the values, so F square upon 4 plus 3F square upon 4. So if I do it like this, then I will solve. So you solve this, what you will get? Let's see. FH I am writing again as F by 2 and FB is root 3 F by 2. So when you are solving this FC, so FC will come, see 4F square, 4 will cancel, so final value will be F. And what is the theta? Tan inverse FB upon H. So what is FB? Tan inverse root 3 F upon 2 divided by F upon 2. So when you will solve, only tan inverse root 3 and this will be 60 degree. Right. So this means if you draw the resultant value, so what you will say? You will say that okay, at point C, in this case, the resultant force will be F, where F is 1 upon 4 pi epsilon Q square upon D square, and this angle will be 60 degree from the reference line. I hope you have understood the concept of multiple charge particles, how we can calculate the value of the force at any particular point if we have multiple of charge particles. So I hope this concept is clear to you. Thank you very much.